Hi guys, today we are going to learn how to solve linear systems by adding or subtracting, and we call this elimination. So I'll write that down. We're solving by elimination, or we call this linear combination. So you can see it both ways, but both terms mean the same thing. So we are going to introduce you to that today. So we are solving linear systems by elimination or by linear combination. So go ahead and title your notes. Before we get started, I want you to look at these two equations. What do you notice? Go ahead and take 30 seconds and write down, what do you notice about these two equations? All right, glad that you did that. Hopefully you said, well, I noticed that I have a positive 2x and a negative 2x. So they are the same number, but one's positive and one's negative. And that's what I want for you to be able to identify. When we're solving these using elimination or combination, it's always great if you can identify if one is a positive number and one's the number, but it's just the negative or the opposite of it. So here are our steps. Step 1, we are going to add or subtract the equations together to eliminate one of the variables. So we are going to add or subtract the equation to eliminate one of the variables. So we're going to form a massive addition or subtraction problem. So I want to eliminate one of the variables. Well, if I add or subtract the 11 or 13 together, I'm not going to get 0, am I? And it's not one of my variables, so I shouldn't pay attention to that. If I look at my y's, I have 3y and 5y. Well, if I subtract them, I'd get a negative 2, and if I added them, I get an 8. So that would not eliminate, meaning cancel out one of my variables. But if I look at my x's, I have a 2 and a negative 2. Well, if I add those two together, they end up giving me 0. So I want to add my two equations together. When I add these equations, I'm adding the numbers in front. So negative 2 plus a negative, 2 plus a negative 2 equals 0. So that's 0x, which means it totally cancels out. So I'm left with 0. I have 3y plus, actually I'm not going to do that because it kind of looks like a minus sign. So I have 3y plus 5y, and 3y plus 5y is going to give me 8y, and that's going to equal, and I add the numbers at the end here too, 11 plus 13, which is going to give me 24. So if you look here, my variables canceled out, and I can now solve for one of my variables, which is y. Isn't that great? So this is a one-step equation, guys. How do you get y by itself? Well, y is being multiplied by 8, so I divide by 8, so it cancels to 1. And what I do on one side, I do on the other. Divide by 8. 24 divided by 8 is 3. Once again, when we're solving, we're still looking for that point. We're still looking for the x comma y. So I'm going to write my answer up here. I just found my y value. It was as easy as that. I added my two equations together. The x's went away. And now I have y equals 3. Now I just have to find my x value. So our next step here is to solve the resulting equation for the other variable. Okay? I'm sorry, that's what we just did right there to find the y. We solved the resulting equation, which was this. 8y equals 24. That was our resulting equation for the other variable. So we got y equals 3. I'm sorry, that was step 2. I got ahead of myself. Step 3, here we go. Step 3 is to substitute in either original equation to find the value of the eliminated variable, meaning in this case the x. So if I have y equals 3, that means I'm going to plug in 3 for y in either my first equation or my second. It does not matter, but what does matter is I have to solve it for x because that was the eliminated variable. Please make sure you have these steps written down. So here's what I mean by that. I'm going to choose equation 1. So I have 2x plus 3y, and instead of y, I'm going to replace it with my number 3 because that's what y equals. So times 3 is equal to 11. So now I'm going to go ahead and solve that. So I have 2x plus 9 is equal to 11. Now I've got a two-step equation. Subtract 9, 2x is equal to 2, divide by 2, x is equal to 1. So now I can come back up here into my answer and put in the 1. So my answer, the solution to both of these equations, remember the solution is where they intersect, is 1, 3. Elimination is as easy as that. It's really it's the easiest form if your numbers play nice together. So let's go ahead and look at these two. So here's example 1 and example 2. I'm sorry, we already did example 1. Check. We already knew that was 1, 3. That's what we just did on the other slide. Take a look at example 2. Okay, example 2. Once again, when you're looking, can you add or subtract either of these equations together for one of them to cancel out? Hopefully you see, again, a 3x and a negative 3x. Well, if you add those two together, they go to 0. So we're going to add our two equations. When I add them, these cancel out. So now I am left with my y's. So I have 4y plus 5y, which gives me 9y, and that equals 8 plus 10. Remember, we're still adding, which gives us 18. Now we're on to step 2. We're solving the resulting equation, which is 9y equals 18, after we added or subtracted, for that variable. So I'm going to divide by 9, so y equals 2. So once again, in my answer, y is 2. Now I'm going to take the 2 for y and plug it in to either of my two equations. Let's do equation 2 this time since I did the first equation last time. Negative 3x plus 5. Now instead of the y, I'm going to replace it with a 2, okay, equals 10. So now I'm going to solve this. So negative 3x plus, well, that's 10, equals 10. I'm going to keep going. It's a two-step equation. Subtract 10, and negative 3x equals, oh, that's 0. That's okay. Remember from our last unit, we still divide. X is equal to 0. So if x is equal to 0, that means up here my answer, my solution is 0, 2. That's where they intersect. So this was adding. Now let's take a look at using subtraction. So I have two more examples here for you. So if you take a look here, I have, for example 3, 4x plus 3y equals 2, and then 5x plus 3y equals negative 2. Well, if you notice these three y's right here in the middle, they're the same, which means if I subtract them from one another, they would cancel to 0, because a positive 3y minus a positive 3y would give me 0 y's. So I'm going to go ahead and subtract these. Now you have to be careful when you subtract that you pay attention to the signs, because this is 4 minus 5. 4 minus 5 is a negative 1x. My y's cancel, which is the point, and I have 2 minus a negative 2. I'm going to write that over here, 2 minus a negative 2. Remember, keep, change, that's really 4. So always go back to that minus sign. Minus can be tricky. Then I am going to divide by negative 1, so x equals a negative 4. So in my solution, I have negative 4, comma, but I don't know what y is. That's when I plug in this negative 4, now for x, in one of my equations. I'll plug it in the first equation. So we have 4 times, instead of x, it's going to be a negative 4. I'm replacing that x plus 3y equals 2. I'm going to go ahead and solve negative 16 plus 3y equals 2. And then I've got a two-step equation again. Add 16, 3y equals 18, divide by 3, y equals 6. So my solution here is negative 4, 6. Take a look at example 4. Oops, sorry. Again, I have, if you have to look at it first, I've got this positive 6y and positive 6y. So I'm going to subtract. 5x minus 7x is a negative 2x. 6y minus 6y is 0y, so it cancels. 4 minus 8 is a negative 4. So I'm going to solve. X is equal to a positive 2. Then once again, I'm going to plug in that 2 in for x. I'll do the second equation. So it's not 7 times x anymore. It's 7 times 2 plus 6y is equal to 8. So 14 plus 6y is equal to 8. I'm going to go ahead and subtract 14 on both sides. So 6y is equal to a negative 6. Divide by 6, y is equal to negative 1. So I'm going to come up here, negative 1. There's my solution. That's where my two equations intersect. Go ahead and make sure you have all that stuff written down. Hopefully I haven't gone too fast for you. Rewind me if you need to. So now these let's see. Okay, we're almost done. These are our last ones. These are examples, okay, of our special cases. So first, take a look. I've got a positive 2x and a negative 2x in example 5, and a negative 10y and a positive 10y. So if you notice, both of them are opposites of one another, right? So if I add them together, because that will cancel out my 2x's, that cancels to 0, but what happens to my y's? I have a negative 10y and a positive 10y. Well, if I add those two together, don't they cancel too? So I'm left with just 0. And on the other side, I have negative 28 plus 28. Well, oh my gosh, that cancels too. That's left me with 0 equals 0. So at that point, when your variables cancel out, just like equations, if you're left with a statement, you have to determine whether it's true or false. In this case, it's true. So that means we have infinitely many solutions. So it's just like solving equations. Infinitely many solutions. All right. Now if we look at example 6. Example 6, I have 9x plus 5y equals negative 25 and 9x plus 5y equals negative 24. Well, to get rid of either the x's or the y's, really, since they're the same signs, can't I just subtract? Well, if I subtract these, 9x minus 9x, whoops, cancels to 0. Positive 5y minus 5y, whoops, cancels to 0. So I'm left with 0. But over here I have negative 25 minus a negative 24. Let me write it horizontally here. Negative 25 minus a negative 24. Well, if you notice, keep, change, change, it's really negative 25 plus 24, which gives me a negative 1. Well, again, my variables cancel, so I have to decide true or false. In this case, it's false, which means that I have no solutions. All right, very similar to equations. Make sure you have these in your notes. Here's your exit slip. You have 4 systems to solve using addition, subtraction, whatever you decide, whatever cancels out one of the variables. And if they both happen to cancel, then you've got your true or false statement, which indicates infinitely many or no solutions. So good luck. Good luck.